Hi class, this is a quick tutorial to show you all what the data sheet looks like from the indirect calorimetry lab, and just kind of walk you through how to make some of the graphs and what I'm expecting out of these types of things. So I know I already talked about it in one of the I know that I already talked about it in one of the videos and kind of drew up some examples of like the types of graphs that I wanted and those types of things. But I just want to make sure we're all on the same page with Excel, and try and save you guys some headaches and time in terms of looking at trying to figure out how to graph some of this stuff. So for Trenton's data, remember that he did, we had him hooked up to the indirect calorimetry machine, the VO2 mask, and we had him doing a variety of different activities. So in some examples, he was sitting, and then he was walking, and then he was running, and these types of things. So one of the first things I want to draw your attention to is this is what he this was the protocol for Trenton's lab. So we have some heart rate data here. I'm actually going to make this center these so they're a little easier to read. So we didn't get heart rate continuously throughout, so the heart rate data is going to be a little bit sort of spotty, but basically for sitting, his heart rate was 58. And then he started walking at 3 miles an hour. Then he was jogging at 5 miles an hour. He eventually made it up to 8.5 miles per hour, and was at quite a high heart rate. And then we see the heart rate come back down. So basically what we're looking for is we want to graph things like his oxygen consumption and his RER during the different periods of time throughout the test. So this data down here is the data that the VO2 machine produced. Now, you might want to become aware of things like this zero line. We can delete that actually and make sure there's no other zero lines. So these are areas where the data did not get collected. So you just want to go through and make sure that you get some of these blips out of there. And you can see that it is it's quite a bit of data, and that's because about every 3 to 4 seconds it took a measurement and gives us things like VO2 total. This is in liters per minute. Actually, I'll put a little note up here for you. Here, this is in liters per minute, and then it has VO2, and you see this little kg, and that's mils per kg per minute. And this is typically what we refer to as the quote-unquote VO2 when we talk about it, or you estimate it out in the field, or those types of things. Remember, in the book, we said that normal resting VO2 is about 3.5, and it does jump around a little bit, but for the most part, it's down in the threes before he, while he's doing this sitting stage from 0 to 9. Okay? So you just need to go through some of these things. RER is another important thing that I want you to consider. Out here, this does it gives you a lot of data, but there's a lot of breakdown on things like the percentage of fat and the percentage of carbohydrates and the amount of calories of fat and the amount of calories. And this is in fat per minute burned. This is carbs per minute burned in calories per minute. And then this is the percentage of fat. So you can see, for example, that the RER here, this relates back to the RER, which gives us information about what substrate is being burned by the system. So under resting conditions, the majority of what we use is fat. And so we see that the percentage of fat is higher than the percentage of carbohydrate. And this will flip later on. When we get to more intense areas, then the percentage of carbohydrate is going to go up. So you can see that it's almost 100% burning fat when he's in his walking stages. So he has a very low RER under these conditions. So we can use all this data and all these columns to basically graph this whole experience. And this is what I want in your lab report. So for example, if you wanted to graph total VO2 consumption across the entire time span of the test, which is a graph that you should consider making for your lab report, what you do is just highlight this entire row, and you can see there was 730 data points, so it's going to be quite a bit of data. But if you highlight both these, now remember the far left hand column is going to end up being your x-axis, and then the y-axis is going to be VO2 in liters per minute. So if we go to insert and then line graph, 2D line, and we click on that, now we have our chart of total VO2 over time. And I'm going to take this up to the top so I can paste it. So I just want to make sure people appreciate. So this is the VO2 in total liters per minute collected over the entire course of the test. So the test took about 35 minutes, and we see 35 minutes down here on the x-axis. And then what we can see are these trends. So his VO2 is of course the lowest when he's sitting, and then it goes up during his walking stage, and then it goes up a little bit more during his running stages, and then as he, at minute 20 we went up to 6.5 miles per hour, and we can see from 20 to 25, which is about here to here, the trend in VO2 increases the entire time, with the maximum being at the end of this 25th minute, around the 26th minute. And then as he starts to walk again, he starts to come back down, stabilizes his VO2 while he's sitting, and then finishes it out. So, or while he's walking and then he's sitting. So we can see, like, here is a walking time. This is all running or jogging. This is walking. This is sitting, and this is sitting. And what you can do is you can use this data to discuss sort of the results from what you saw in this lab. So you've seen Trenton exercise on the treadmill, go from sitting to running vigorously to walking to sitting again. And we've measured the entire thing using indirect calorimetry, and we can gain insights into what percentage of his age predicted heart rate max, how high his VO2 got, what his and then also really importantly the RER. So the RER again gives us insight into the carbohydrates and fat that were used as a fuel during different times, and we can see that during the higher intense times he becomes less efficient. Trenton becomes less efficient, and he increases his reliance on carbohydrates. So I think between all the material that I gave you for Lab 3, so if you watch the lecture, then you watch Trenton's test, then you look at the post-lecture where I talk about what expectations I have for the lab write-up and the graphs and those types of things. And then you also watch this video and get some insight into how to make graphs. I think you're going to be well set to create a really nice lab report for this. So part of the lab experience is working with data sets and trying to interpret information that was collected from the lab. Now, for the on-campus students, some of the point is some of the experience is kind of being in the room and seeing it all happen in real time, but we've tried to capture that as much as possible. And the reality is only one person is getting to actually participate and I'm kind of running the test and people are observing. So the students online are still getting a very similar experience, especially with the audio lectures, with the whiteboard markups, with these data sets. And I really want you guys to not wait till the last minute and take some time sort of with your hands in these data sets, sort of trying to see if it clicks in terms of making these graphs and figuring out how to make them and what they mean and how to mark them up and stuff like that. One of the suggestions I made for the on-campus class is that, for example, you can take this chart here and save it as a picture and then import it into PowerPoint. And then in PowerPoint, you can put little arrows that sort of say, for example, this stage here was the walking stage, and then put, say, an average VO2 for that period of time. And then this was walking at 3 miles an hour, this was jogging at 5 miles an hour, and you can kind of average these different sections of it. So from 0 to 9, for example, if we wanted to know what his average VO2 was for this sitting stage from 0 to 9, we would just highlight the time points from, kind of flew past it there. We would highlight the data from 0 to 9 minutes, and then we would average that using Excel, right? So you can just hit equals, whoops. You have to select it. And then I would highlight this entire thing down to pretty jumpy. It's easier to go to 9 and then go up from there. And then you just hit enter, and that's the amount in liters per minute that was the average intake for the that was the average intake for his total oxygen consumption at rest. So for example, you could take this number. Let me try and blow it up a little bit so we can see it easier. So you take this number, and this is in liters per minute. And so, for example, if we took this number and multiplied it by, so you take liters per minute, and if you multiplied this by 1440, that's the number of minutes in 24 hours. So we could estimate, for example, that Trenton consumed 474.5 liters of oxygen. He will consume 474.5 liters of oxygen if he just sat still in a chair awake all day for 24 hours. And we know, for example, that per liter of oxygen, we burn 5 kilocalories. So we could then take this number, 474, and multiply it by 5 kcals per liter, and end up with calories burned in a 24-hour period for a resting, if he were to just sit still awake. So, for example, Trenton's estimated or measured through indirect calorimetry, his BMR, his basal metabolic rate, his RMR, his resting metabolic rate is 2,372 calories. And that makes sense for a person that is young, weighs 195 pounds, and has fairly low percent body fat. So the point here is that you can use this data here to get averages during the different stages, to make estimates, to understand what types of fuel he's using under different circumstances. And I really want to encourage you all to kind of get your hands dirty in this data. One more thing that I want to show you is that to make graphs for the RER, for example, you can highlight your section of time. So actually, let's go to 9 minutes, for example. So this is the sitting stage. And then if we want to if we want to graph the RER over the sitting stage or over the whole time period, we would highlight a section over here, and then you hold down the control button, and that's how you highlight what ends up being the Y column. So now we have the X column highlighted, the Y column highlighted, and this is so you can do it without the columns being right next to each other. And you can just click Insert, Line Graph, 2D Line Graph, and we end up getting our, oops, I did that wrong. You have to label one of these. So you highlight a certain section of that, bring this over here. Hold down Command. Highlight a section of that. Insert, line graph, and we get our RER over time. Okay, so I hope that this makes sense. I hope that this helps out, and good luck interpreting this data. Email me if you have any questions, and I hope all these kind of tutorials and showing you how to use these graphs and things like that is helpful. This is actually really applicable, and so it's one of the reasons why I'm taking so much time to explain it and do all these screen captures and videos and things like that, because knowing how to analyze data sets like this and then create graphs that represent the data in Excel and present that in a coherent way is an extremely valuable skill, regardless of the field that you're going to go into. But it's really, really important if you're ever going to be responsible for generating reports and these types of things, which is a skill that everybody needs to have. So I hope this is helpful. Again, just email me, let me know if you need any sort of clarification, and good luck.